Back in 2017, a mysterious traveler we named Oumuamua shot through our solar system, leaving a trail of questions that we're still trying to answer. Then came a second visitor, 2I/Borisov, which seemed a lot more familiar, but only deepened the mystery in its own way. Well, it's happening again. Astronomers have just spotted a third object from the depths of interstellar space, and it's called 3I/Atlas. It's bigger, it's faster, and its chemical makeup has scientists scratching their heads. We have a very short window to unlock the secrets of its alien origin before it vanishes back into the void forever. What are these silent messengers? And what can this new visitor tell us about the universe beyond our own cosmic backyard? On July 1st, 2025, high in the mountains of Chile, the Atlas telescope system picked up a faint, fast-moving speck of light. At first, it looked like just another asteroid, but as astronomers tracked its path, they realized this was no ordinary rock. Its trajectory was a hyperbola, an open-ended curve that meant it wasn't gravitationally tied to our sun. It was a tourist, just passing through. This was it. The third confirmed interstellar object in human history, officially designated 3I/Atlas. And this tourist is in a hurry. 3I/Atlas is screaming through our solar system at a mind-boggling 245,000 kilometers per hour, or about 68 kilometers per second. That blistering pace is a dead giveaway of its interstellar nature. It's moving so fast that the sun's gravity can't possibly capture it. This incredible speed suggests it has been drifting through the vast, empty space between stars for an exceptionally long time, maybe even billions of years. Unlike our first visitor, 3I/Atlas is active. It has a glowing cloud of gas and dust around it called a coma, and it's even developing a tail. This tells us it's a comet, not an asteroid. But as we're about to see, it's not like any comet we're familiar with. The clock is ticking. The object will make its closest approach to the Sun in late October 2025, passing just inside the orbit of Mars before it speeds away forever. This gives scientists a precious, limited time to study it and learn the secrets of its alien origins. To understand why 3I/Atlas is such a big deal, we need to look back at our previous interstellar guests. Think of them as the first two data points in a cosmic puzzle we're just starting to solve. Our first visitor, 1I/Oumuamua, was a complete enigma. The name roughly translates to messenger from afar arriving first, and it was bizarre. It was small, reddish, and apparently shaped like a cigar. Most confusingly, it didn't have a comet's tail or coma, which suggested it was a dry, rocky object. And yet, it accelerated away from the sun faster than gravity alone could explain, something we usually see when ice on a comet vaporizes. This paradox led to intense debate, and even some wild speculation that it could be an alien artifact. Then, just 2 years later, 2I/Borisov showed up. Discovered by amateur astronomer Gennady Borisov, this second visitor was honestly a relief to scientists. It looked and behaved exactly like they expected an interstellar comet to. It had a visible coma and tail, and its chemical makeup was pretty common in comets from our own solar system. Borisov was the confirmation that our theories about how planetary systems form and eject material were generally on the right track. It told us that interstellar space should be full of icy bodies flung out from distant star systems. So we had one weirdo and one normal comet. Oumuamua was the anomaly, Borisov was the baseline, and that's the context for our third visitor. Everyone expected it to be another Borisov, another reassuring piece of the puzzle. They were wrong. As soon as 3I/Atlas was confirmed, the world's most powerful telescopes, including Hubble and the James Webb Space Telescope, turned their gaze toward it. The initial images were stunning, showing a clear, teardrop-shaped coma streaming from its icy core. It was definitely a comet, but when the spectrographs went to work, breaking down its light to read its chemical signature, the results were odd. Early observations revealed something astonishing in the gas surrounding 3I/Atlas, an unusually high abundance of carbon dioxide and methane. While we find these compounds in our own solar system's comets, the sheer amount detected in 3I/Atlas was strange, hinting that it formed in a very different and perhaps much colder environment than our own. It's like finding a fish from the deep ocean swimming in a freshwater lake. Its very chemistry screams that it comes from a different kind of place. Every new piece of data just deepens the mystery. This isn't just another Borisov, it's a new kind of puzzle piece altogether. Of course, some have wondered if these strange properties point to something other than a natural object. The prominent astrophysicist Avi Loeb, who famously suggested Oumuamua could be an alien probe, has floated the idea that 3I/Atlas could also be technological. However, the vast majority of the scientific community agrees that its active coma and tail are consistent with a comet, albeit a very, very strange one. So no, it's probably not a spaceship. It is, however, a messenger carrying clues about how worlds are born far beyond our own, and the message it's bringing is that the galaxy is far more diverse and surprising than we ever imagined. The discovery of 3I/Atlas, with its peculiar chemistry, forces us to ask some really profound questions. What are these things, and what do they tell us about our place in the galaxy? One of the most mind-bending ideas comes from tracing 3I/Atlas's path backward. Some models suggest it didn't come from the part of the Milky Way where our Sun lives. Instead, it may have originated from the galaxy's thick disk, a region filled with much older stars. If this is true, 3I/Atlas could be astonishingly ancient, maybe over 7 billion years old. That would make it the oldest large object ever observed in our solar system, a true relic from an earlier chapter of the galaxy's history. This also connects to another revolutionary idea, that interstellar objects could be crucial for building planets. The process of planet formation has a major bottleneck. Models show dust clumping into boulders, but at around a meter in size, these boulders tend to just shatter or bounce off each other instead of growing larger. But what if a star system doesn't have to start from scratch? Researchers like Suzanne Faltzner have proposed that interstellar objects could act as seeds for planet formation. A young star system could capture millions of these ready-made planetary building blocks, bypassing that meter-sized barrier and giving planet formation a huge jumpstart. It's an incredible thought. The giant planets in our own solar system might only exist because a wandering visitor, a lot like 3I/Atlas, was captured by our young sun billions of years ago. These objects are so much more than cosmic curiosities. They are samples from distant solar systems delivered right to our doorstep, fragments of alien worlds, carrying direct evidence of the conditions around other stars. While sending a probe to another star is centuries away, the galaxy, it seems, is sending probes to us. So in just a few short years, our census of interstellar visitors has gone from 0 to 3, and each one has told a completely different story. Oumuamua was the oddball scout that defied classification and opened our minds to how strange the universe can be. 2. I/Borisov was the familiar cousin, the classic comet that told us our basic theories were sound. And now, 3I/Atlas is the ancient paradox. It looks like a comet, but one with a chemical fingerprint from a time and place far removed from our own. These silent messengers are rewriting our understanding of the cosmos, one fleeting visit at a time. And this is just the beginning. The Vera C. Rubin Observatory is about to revolutionize the hunt for these objects. With its incredible ability to scan the entire southern sky every few nights, it could find dozens of them every single year. What are now historic discoveries will become a steady stream of new data. We are standing at the dawn of a new field of science, interstellar archaeology. For the first time, we are able to study the relics of other solar systems up close. Each new visitor is a clue, another piece of the grand puzzle of how planets form, how solar systems evolve, and maybe, just maybe, how common life is in the galaxy. We just have to be ready to watch. Thanks for joining me on this journey. If you enjoyed it, please hit the like button and consider subscribing for more deep dives into the cosmos. Until next time, keep looking up.